So today I'll be speaking about eradicating flaky tests. I'm not going to speak much about myself, but you could reach out to me on Twitter or LinkedIn. My Twitter ID is there on all the slides. I would love to get connected with you and have offline discussions as well. So let's get started with the topic itself about how do you eradicate flaky tests. I'm not going to talk about what are flaky tests. I'm assuming you already know what are flaky tests. As part of your test execution, tests keep failing intermittently. You don't have any idea why it is failing. But what I'm going to, and I recently published a blog on Applitools website. Feel free to look it up. It's a very comprehensive post about what are the different reasons why a test can be flaky, and also how can you remove these aspects of flakiness from your execution. But today we will talk about specific techniques, and I will also show you a demo of how you can actually remove flakiness from a test execution. And believe me, it is not at a snap of a finger that is going to happen. It is going to require a lot of hard work. But I have seen in many occasions, many projects that I've worked on, worked with customers, worked with clients, these approaches do make sense. They do give a lot of value from your feedback perspective. OK, so let's take a quick example of a typical product. And this is a complex product that is there, where you would have different types of front-end applications as seen on the left-hand side, which are out on the internet. These applications could be for support, it could be for onboarding, it could be B2B type of applications, B2C type of applications, and they could be available in form of web or native apps, does not matter. But what happens is these applications connect to your application under test, your system under test, via some gateway, via some authentication mechanism, which ensures that these are the correct set of people reaching inside your network. And then you would have a lot of different components of your architecture of your system, how they interact with each other in various different tech stacks. And also there would be a lot of different types of data stores, or whether it's databases or Elasticsearch. And complex systems usually have a lot of integrations with external systems, external to that organization itself, or external to this particular product, but part of the same organization. Does not matter. In the scope of testing or the scope of functionality that we are trying to validate, these are external systems. And that is what you see on the right-hand side. These are the external systems that are there. I hope this type of architecture resonates with all of you. So if this is the type of product that you have, my question is, how are you going to approach your API workflow automation or your end-to-end test automation in such type of ecosystem? So the first thing that you would do is you would try to implement some automated tests, whether at the API level or at the functional UI level, trying to simulate what your front-end applications are doing, how the users of these front-end applications are going to be interacting with your product, what business scenarios, use cases are they going to try and achieve, and you will try to simulate these scenarios as part of your test automation. OK, this is typically what we always do. This is typically what the automation team is going to do, whole developers involved in implementing and running these tests. But when it comes to running tests of this, there are certain set of challenges when it comes to implementing these tests in a deterministic fashion. When I say deterministic, you should be able to get the right type of results as per expectations of the test scenario in a reliable, consistent fashion. So the challenges that you typically face in such cases is one, that these type of scenarios are usually long-running scenarios. You would start off with launching the app or once go to the home page, log in, and then you achieve all the different steps of the workflow. What it also means is that it takes a long time to implement these end-to-end scenarios that your users might be doing. Hence, the feedback cycle is slow. Second, these tests are brittle or they are flaky. Why? Because there is a lot of dependencies that the tests have on the system under test, on the application under test. There are so many different components of your architecture of your system that are interacting with each other, including the external systems. And this is not even counting the type of changes that happen in your application as your product evolves. So any small change in any of these parameters, including network conditions, can cause your test to fail intermittently or in weird fashions. Also, the data dependencies in such type of systems is complex. How do you set up the data in a correct fashion, which will be available for every test run, for each and every execution of that test run? The other challenge that you come across typically is the limitations of how many scenarios can you really automate, given that all these different pieces of your architecture are glued together. How can you simulate error cases, edge cases, especially from your dependent systems, because you cannot really control them. Your components of the architecture internally are going to call these external systems, and there's no way to really control the type of behavior that these systems would have, especially from the test side of it. Another challenge is how do you really simulate different conditions of inbound requests coming in from your external systems into your application. It's not the client side apps, but the external apps are external systems are calling your product. How do you really implement those? That's another challenge. The last challenge that I want to talk about is cross-browser testing or cross-platform testing. We know our users are not just on one browser or one version of the browser anymore. Long gone are the days, and thankfully they're gone, where you have just one browser installed in the computers and that browser version is completely managed by a central IT team. Now, your users could be on any type of browser, any version of the browser. They could be connecting either from your office, or everyone is working from home these days. Or you could be on the road and you are connected. So varying network conditions also come into picture. And if you're on the road, then that means you're connected via some portable device. That means the browser variations or the device variations become even more compounded, more intense, right? So how do you make sure your product works correctly across all the different types of browsers or devices in various different types of network conditions as well? Your product has to continue working well, functionally, as well as the user experience needs to be consistent. So these are the various challenges that come across when you're testing such a complex system and you're building automation from an end-to-end perspective, whether at UI or API level in such an ecosystem. So what are the ways forward? What are the solutions? How can you actually start making this test automation add more value to the team? How can you improve the ROI? So I term this as reducing flakiness from your execution. How can you remove these challenges and also flakiness from your execution because of such a complex ecosystem? And there are three solutions that I want to talk to you about. And these are complementary solutions. This is not one or the other kind of approach. These are complementary solutions. So the first one is you need to reduce the number of UI tests. If you have less tests on top of the pyramid, you will have less flakiness and you're going to get faster feedback. Second, you need to remove the external dependencies via intelligent virtualization, and then you'll be able to test better and test more comprehensively. And third, you should use visual assertions instead of relying purely on functional assertions as part of your automation to get more coverage and less brittle tests. OK, let's explore what it really means for each of these aspects. First thing, reducing the number of UI tests. I hope everyone is familiar with the concept of the test pyramid, where we've got various different types of tests. For simplicity, there are just three types of tests listed here: UI, web service, and unit tests. But in reality, these could be many more types of tests where as it is applicable to your product under test. The idea is you should have maximum tests in the lower layers of the pyramid because that's going to be faster feedback, more isolation, and cheaper to implement and execute. And on top of the pyramid, these tests should be minimal in number because these are slow. There is more integration required, hence it is more expensive as well to implement it. To take it a little further, the web service tests, you need to make sure these tests are of various different types. You should think about these as workflow tests, API tests, and also contract tests from a consumer as well as provider perspective. And these types of tests will give you a lot of value from the feedback of your code quality perspective. OK. Another important thing to realize is the test pyramid also includes user experience and the non-functional requirements like accessibility, analytics, performance, security, and there are many more NFRs that are there. But you need to make sure that test pyramid includes that as well, because all aspects of these automation, including the manual exploratory testing that you do, is going to give you fast feedback. That is going to indicate the quality of your product. OK, so the first tip to eradicate flaky test is reduce the number of tests. If you have less code, you are going to have less defects. Same thing, if you're going to have less tests at the top of the pyramid, the nature and amount of flakiness is going to reduce. Let's move on to the second one, which is a more actionable item than a concept, right? To use intelligent virtualization to eradicate dependencies. So again, if you remember our typical architecture of a system that we have, and let's take a use case for what type of test you would want to be writing over here. OK, so the typical test that you might have is that the approach, of course, is we are going to simulate this from the front ends using API or UI. And if I need to now automate some scenarios having external dependencies over here, what are we going to face as challenges? So let's take a use case of a test that needs to be automated. First part of the test, first step is a test is going to make some API call, which is after authentication is going to go to a particular service. Let's say that is service number 2. This service does some processing, and as part of that processing, it also calls an external service, which may be unavailable. It's not in your control. Maybe there's a deployment going on. Maybe it is down for whatever reason, you don't know. But if that service is unavailable, you get an error back from as part of that call. And because this service 2 gets an error as part of its processing, it is going to return an error to the test. As a result, your test fails because some external dependency was not available. And that is completely out of your control. Your service may have been, service number 2 could have been behaving absolutely correctly, but your test validation has failed in that scenario. And that is a problem. And that is the type of challenges that you would face a lot when you're writing tests against such type of systems. So what is the solution? We need to stub it out. And one of the approaches, solutions that I've used, I'm a contributor on this as well, is using an open source tool called Contract. Contract's primary purpose is to enable contract driven development. When two different parties within a system or out of external parties need to communicate with each other, there is a contract based on which development and implementation would start from a provider perspective and consumer perspective based on the agreed upon contract. And contract driven development tool named Contract, again with a Q, is a way to automate this interaction and make sure the contract is not failing in all these situations as the implementation goes on. At the same time, decouple the requirement of the provider being available first for the consumer to be able to start using it. This will allow parallel development to happen for you. In a nutshell, Contract has a lot of different features and capabilities. The key thing, as I mentioned, it is an executable contract spec, and it has got a lot of different features from a service virtualization perspective, ensuring backward compatibility, versioning, and also it supports various different formats, JSON, XML formats, and Kafka. And there are many more formats that are in the roadmap for implementation. But as part of this end-to-end conversation or test automation conversation that we have, contract plays a very interesting role over there. We will use contract as part of our test execution itself in a test environment. And for that, what would happen is on the left hand side, we already had seen this, where our API workflow tests or the functional tests are going to simulate the user actions. On the right hand side, you will see the external systems, they are stubbed out using contract, which is an intelligent virtualization tool in this particular use case. So how this would work in our earlier example, first thing, the test is going to, we need to start a contract as a stub server in our environment and make sure all our external services are stubbed out and the internal services which rely on the these external endpoints, they point to the contract server instead. OK, that is step number one, which is a one-time activity when the environment is set up. Of course, the same thing would need to be done whenever redeployment happens. You need to restart contract server as part of that. Then when it comes to the test execution, the first thing that would happen is the test is going to set some expectations on the contract server for a specific stubbed endpoint. This is a post call, a simple post call with the test, which the test can make and set up this expectation on what should the response be if the contract stubbed endpoint gets a specific request. It's an actual mapping of what is my request that is coming in and do I have a corresponding response that I should be giving out over here. And that is expectation that I'm setting on the contract server. Note that if I do not have an expectation set, contract server will give you random responses based on the contract spec of the correct data types, and that is going to be given back to the caller. OK, so this is step number 2. The test is going to set the expectations. Then the test is going to call service 2, which is the same as before. Service 2 will call the stubbed external endpoint in this case instead of the real external endpoint. And now because there is a matching expectation set on it already, the contract stub server will return the type of response that the test wants the external endpoint to give. Hence, service 2 is going to process it correctly and respond to your test. And the test is going to assert based on is service 2 responding in the fashion that is expected for this particular scenario. OK, so I hope that makes sense what that workflow changes, right? There are just 2 additional things required. One, setting up of a contract as a stub server to stub out the external dependencies. And second, the test is going to set expectations on the stub server as per its requirements. And that makes it very powerful to test out various different scenarios from an edge case, negative case perspective as well, including happy paths, without having to rely on if the external system is really available or not. OK, here's an example of what we'll be seeing later in the demo as well, where the test is actually going to do a login. The test scenario points to my application under test, of course, and one of the APIs in my application under test has a dependency on some external endpoint, right? So my test makes the login call. The test gets a list of users, but my application doesn't really have that list of users. It is going to make the call externally, get that response back, and accordingly the scenario would continue. So in this case, what we are going to do as part of our test implementation is the test is going to, instead of working with an dynamic set of users which comes externally or invalid set of users that comes out externally, which would result in the test scenario failing, we will stub out the external endpoint and we will work accordingly. OK, a quick example of what the contract spec looks like. It is specified in simple Gherkin language, simple given when then, where you could specify exactly what the request needs to be, what is the response payload, and these can be complex objects as well, a complex structure. You should be able to create it very easily. It would also have a specific method, the endpoint where you're making the call, specify any headers as might be expected. And then when you make such a call, what is the response that you expect for this type of request and the body as well. So this is how the contract spec is going to be designed. The key thing is this spec will run as a test from a provider as well as consumer side as well. That's why it's an executable spec, and that's what makes it extremely powerful. So very quickly, I will show you what the code looks like for this. This is a simple Selenium WebDriver based test where I would of course not be implementing the test in this fashion. I would have a proper framework created, but in context of a demo, it makes it easier to show everything in one test class itself. So over here, I've instantiated my Selenium WebDriver and I set my expectations on the external endpoint over here as part of this call, which is a simple post call that would be happening. My test is going to do whatever navigation is going to be required to implement the functionality, and it will do the assertions accordingly. Now, the key thing over here is this application that I'm testing is hosted locally on my machine. It could have been deployed in a particular environment, which is not a problem. But the key aspect over here is it is one of the external endpoint calls that is made by the application is stubbed out using contract, and the contract spec has been defined in this fashion. So when I have a contract spec defined, I would be simply starting my application under test, which is running right now as an NPM package. I would also start off contract server because this is all on local from a demo perspective. Contract server is also running on local right now. And because one of the endpoints is stubbed out, you would see that this is a stubbed endpoint that it has already served. And when I run my test, it is going to trigger the functional test execution based on what we saw over here. The first, let me actually trigger this test. This will launch a browser because this is a UI based test. Now login is happening locally. There's another component which is running over here. I'll talk about later, but you see this list of users that came back. If I did not have the external endpoint stubbed out, I would get a random list of users over there. However, because I have it stubbed out and my test is about editing an existing user, a specific existing user, my test would fail because every time I get a random list of users back. But this test is going to pass because of my stubbed endpoint returning the same set of users, and I'm editing it, making sure I'm able to validate my functionality under test, my application's functionality under test. And that becomes very powerful. OK, I hope this concept is clear. So moving to the next part of how can we remove the flakiness. The next part is about how can you use visual assertions instead of functional assertions. We have spent all this effort in automation. We have done various different types of automation over here, right from unit all the way to the UI layer and NFRs, but defects still escape into production. Bugs still escape. And you would see cases like this across the globe in various types of applications, whether it is airline website where some text is overlapping, or if it's a banking website or any others, right? It does not matter if your application is a native app on a specific platform or it is on the web. Is it for B2B type of users or it is B2C users? Does not matter. You will see these types of issues, functional and visual issues, across all of them at some point in time. And I would really question why you are spending and putting in so much effort in all this automation, but still defects escape. And if you introspect why this happens, it is because Yes, of course, you cannot prevent defects from coming into the system. But the point is, can you reduce these types of defects which can easily be avoided if our testing approach is made better? Right? That is a key thing. Bugs escape because our approach to testing is not necessarily correct. We have to think about how can we optimize our testing approach to make sure whatever can be caught as part of our testing is caught, and really the ones which you could not have thought of, those are the only issues that escape into production. So the reasons why these defects escape is because we get very mundane and easily bored because our approach to testing is tedious. These are mundane activities that we keep doing every time, repeating it build after build. The way of testing is very tedious and you're constantly running against time. There's always a release to be done as quickly as possible, a defect to be fixed and hotfix to be released to production as quickly as possible. But what that leads to is a lot of error-prone way of working, which results in defects escaping, which could have been caught had you thought through better about your approach. So let's do a quick exercise. Since this is virtual, I will not ask for responses right now, but feel free to add this in chat comments as well. If I show you these images and ask you what are the differences in these images, how quickly can you tell me how many differences are there? I'll wait 5 seconds before I proceed. OK. In this case, there are 4 differences found. And the point I'm trying to highlight over here, this is typically what our approach to testing is. We might have automated a lot of things, but from a visual perspective, first of all, our functional coverage might not be complete. That's the first part. Second, because of it being incomplete and certain aspects that cannot be validated from a functional perspective, you have to rely on humans taking a look at it and ensuring everything is fine. And typically, this is a type of approach that is taken where you are doing spot the difference type of approach, right? You quickly look at the screen or the app and see if this is what is expected, and if not, proceed. This is happening very quickly. But are you repeating this for all the different browsers that are there, for all the different viewport sizes to make sure responsive nature of your product is working well, or on all the different types of devices where different form factors might be there, where the portrait landscape is there and tablets also comes into picture, right? How often can you do that in a thorough fashion to make sure none of these types of issues escape? OK, that is the problem of our testing approach. So what is the way forward? We need to take help from computers to make sure it can replicate what the human eye and brain can do and tell us very quickly if there is a problem in what is being seen, in how the page has been rendered, and is that working correctly or not. And that approach is what is called as visual AI. So the product that I'm going to talk about now is the creator of visual AI, Applitools. And I'm going to give you a quick understanding of how Applitools solves this problem from a visual rendering perspective. So visual AI ignores the differences that users don't really care about. So if I flip between these two screens, one is rendered on Chrome, the other on Edge. How many differences can you find over there? Clearly, there are a lot of differences that are visible to the eye immediately, right? The payroll processing made easy and the content after that is rendered completely differently. And there's some text overlapping or word wrapping also not happening correctly. The screen also seems to be moving enough for the eye to capture that. But do your end users really care about these types of differences? I don't think so. Instead, what the users care about is this really working correctly from a functional perspective? And what you notice is that there is certain thing missing on the bottom right hand side of the screen, which probably was not visible very easily when I was flipping between the two types of screens. So visual AI focuses on differences that matter to the users and not on the rendering or differences, pixel-based differences that users don't necessarily care about. And the reason over here is that pixel comparisons are a lot of false positives. These two screens, images on the screen right now, are related to the same screen on different devices. And over here you see that the whole screen is highlighted in pink because at a pixel level, on the whole, almost the whole screen is different at a pixel comparison level. However, if you use Visual AI will highlight the differences that actually matter. Is the store open or closed? Or what are the timings of, is it open on weekends or not, right? So it focuses on the differences that genuinely matter to the product, to the end users. And the Visual AI technology that Applitools has, it works across PDF forms, native apps on Android, iOS, and across all the popular browsers that are available in the ecosystem today. It also works with a lot of different types of complex pages, whether it is PDF forms or images, dynamic content. Visual AI is able to process all of those and give you the right type of results. OK, so let's look at a demo of what this really means, right? So we already saw the functional demo of how this was implemented, where we have stubbed out the external endpoint and we are running the test from a functional perspective. We saw functionality wise, our test has now become consistent because we have stubbed out the dynamic data, giving it the same data every time and making sure the functionality of my application under test is working correctly. OK, now let's look at how visual testing comes into picture. So over here, what we have is, you would have noticed earlier, there are method calls like eyes.checkWindow. What this does is, this is Applitools Java SDK, the Selenium Java SDK integrated into my automation code. Simple couple of lines of code and it is integrated. And over here, what we have done is, every time I want to do some functional assertions or visual assertions, I'm just going to call methods like eyes.checkWindow. And this I can repeat as many number of times that I want in my test implementation. OK, so all I'm using my Selenium WebDriver, which is a functional testing tool that I'm using in this case. I'm using that to drive my application under test to do the various actions that are required. And I'm using Applitools to do the functional and visual validation for me. I do not have any assertions in the code over here because I do not need to. Applitools is going to take care of that for me. And how is that going to happen? Let's quickly take a look. We ran the test a little while as part of the earlier demo, and I also have run the test multiple times today. My mouse seems to be disappearing. OK, here we go. So when I ran the test, for every eyes.checkWindow call that I did, Applitools has captured that screenshot, the DOM and CSS information, and it is going to compare that with an available baseline. Baseline is something that is expected for that particular page, and a checkpoint is what was the screenshot captured when the test ran at this particular time. It also says which OS and browser the test ran on for the comparison, and which is the AI algorithm that was used for comparison. Now in this case, because I'm using a layout algorithm, I do not see any difference over here because the layout algorithm is an AI algorithm which says I don't care about the content. I just want to focus on the structure of the page. Is everything working correctly as expected? And that is what I'm doing over here. I'm focusing on the content of the page. Nothing seems to be the problem over here. I continue, and over here I see from a structure of the page perspective. In this case, the content also is the same, so that's a coincidence in that sense. But as a layout algorithm, I'm able to find a difference which is highlighted here, that there is certain additional functionality that is there in the screenshot that was captured compared to my baseline. Now this could be a defect in the product, that something additional is coming here, or it could have been an evolved functionality of the product, which means going forward there is going to be a button over here. And I'm seeing this as a value add immediately. Now, this is not just a visual defect, right? Though we are using Applitool as a visual testing tool, this difference that is captured over here is actually a functional defect that has been captured, right? So that's the reason why I do not need to write assertions for each and everything as part of my functional test. I'm going to use Applitools to test visually and functionally if everything is fine. Now, at this point in time, if I have root cause analysis enabled, I could click on the difference and it will tell me what is the difference in the DOM and CSS because of which this issue has come across. Right? And that becomes a very powerful way for me to hand it over to my UI dev to say, here's the reason why the difference came across, fix the problem. And this is, of course, assuming that this is a defect that was captured. So in this case, what I could do is if this was a defect, if I have Jira integration, I could report this as a defect, of course, a meaningful name, assign it to the developer. And at this particular point in time, if I do a thumbs down, now this test has been marked as failed, or this particular checkpoint has been marked as failed. And similarly, I can proceed and see all the others as well. OK, so this is the value of what Applitools can bring to me using visual AI in my tests can bring to me to get validations across functional and visual testing aspect. OK, now another very important aspect is, I'll quickly switch back to the slides. There's a very important concept. Yeah, there we go. So what visual assertions is doing for me is a single assertion is going to give me the full functional coverage as well as validate the UI. It does not break when the UI changes because it is going to, you're not relying on locators of the page to do the assertions over there. There's no coding skills required to maintain the baselines. You saw there were simple clicks that you could do to update the baselines or report defects. OK, and now the most important thing, you can validate the user experience at scale for all the supported browsers and devices for that matter. And the way it would happen is in the Applitools configuration, you can provide all the different browsers with the different viewport sizes that you have, including devices as well. And once you do this configuration and run the test, every eyes.check window call is going to do something like this. Your test is running on local machine or your dev QA machine or CI machine. Whenever the test runs and you do eyes.check window, Applitools will capture the DOM and CSS information, send it out to the Applitools ultra-fast grid. The ultra-fast grid is going to re-render the same page in the browsers that you have specified. And once the rendering happens, it will do a validation with the Applitools ICE server from a baseline comparison perspective. So what this means is that your tests are going to run just once on your local machine, but for all the configurations you have specified, your test will be visually compared and visually rendered and compared for all the different browsers, devices that you have mentioned, and the comparison would happen automatically and you get the results back. Now, if you want to run your tests at scale, you can just spin it up in a grid or run the tests in parallel on your own, again on the same machine, but only one browser is required. The same approach will work every time you do eyes.check window, render it in the ultra-fast grid in that browser and viewport size, do the validations and get the results back. OK, so what this means, right, is it covers all the environments at the speed of running a single test, and that is very, very powerful. The tests become much more robust and stable. It covers functional and visual across all these configurations. There is no security vulnerabilities because now if you see this earlier screen, there is only an outbound request from your company firewall into the ultra-fast grid. There is no inbound connection coming across, right? So there is no security risk over here because there's nothing coming back inside your network. Because you're not running your tests on all the different browsers or devices repeatedly just to get coverage, you don't have the requirement of additional test data as well, nor a network load perspective is something that you need to consider. It will take care of all of that in the Applitools grid itself. OK, and as a result, because of all these benefits, it also costs significantly less compared to running your tests in a cross browser fashion, the traditional cross browser fashion. as we saw earlier. So now if I have to run this test across all these different supported browsers that are there, right? Here is what my configuration is. This is a sample configuration where I can specify i10, 11, Chromium, Edge in Chromium or Legacy, Safari, Chrome, Firefox, of course, and all the devices. And Applitools takes care of these browser version updates that are coming across. You don't have to worry about that. We'll provide you ways to just say, I want to use the latest Chrome or one version back or two versions back. And that's about it. You just specify that and run the test. It works just out of the box. And what would happen in such case, right, when you run the test with all these different browsers, configured in the Applitools grid, what you see over here, the test ran just once the way I ran it. So actually, as part of my demo that I ran the test ran just once, but I had the ultra-fast grid configured as part of that. So you see there are so many different executions of the same test happen automatically. I did not have to do anything. And now what this is telling me is basically at scale, when I'm running it in different browser configurations, different viewport sizes, I'm getting the validation happen automatically over here, including for my mobile web as well, which seemed to pass. There was no difference found from a mobile web perspective, right? So from a single test execution, you are getting functional and visual coverage across a lot of all the supported browsers and viewports that your application might have. And that makes it extremely, extremely powerful from an execution perspective. OK. So what does this mean in summary? You have to make your automation intelligent. And intelligence is also about thinking about what is the right type of test to automate or not, and how is that going to provide value to you. So reduce the number of UI tests, follow the test pyramid, use visual assertions instead of functional assertions. Applitools is a great way where it is not pixel-based comparison. It actually uses AI to do these validations in a very precise fashion. There are more than 1 billion tests that I've run on the Applitools platform, and the accuracy of the AI algorithms is 99.49%. That's a huge level of accuracy, and a lot of these tests and existing customers are approved to the value it can generate. Use intelligent virtualization in your environments to stub out the external dependencies and do thorough testing without the limitations of having external systems integrated in your environment. Use contract for that. There might be other tools as well, but contract is a great way to enable contract-driven development, and external service dependency virtualization is one of the benefits that you get out of that as well. And that can help you significantly. OK, so I hope this helps you in thinking about how you can reduce the brittleness of your tests, virtualize these tests, the systems as well. And this is all part of an existing automation, so you don't really have to do anything very different from automation perspective. So with that, here are a list of references that I have referred to. There is also sample code that I have checked in, which is also available over here. I will make sure that link is also available, the code that I ran. You can just check out that repository and run it and see how you can get value out of intelligent service virtualization and visual assertions using Applitools. With that, I'm going to stop over here, and I'll jump into questions to see if there are any questions and how I could help address some of these.